Okay, welcome back. I hope we had a great spring break. Happy Monday. We've got continuation of the stuff that we did like a week and a half ago. We're just going to pick up as if we saw each other a couple of days ago. Today we are going to cover something called roots and radicals and rational exponents. Again, this is a whole big section right here about radicals and exponents. So this is our fourth day on radicals and or exponents. Next class, working with radicals. There's that same word again. It'll be our fifth day. And then finally, we change gears and we'll talk about products of polynomials, and that will shift us into a whole new section of the, or whole new unit, a theme in this class. All right, so tomorrow is essentially the last day talking about radicals and exponents. Coming up, quest number 3 is on April the 4th. When is that? Is that Monday? Yeah, okay, so 1 week from today, quest number 4. Not too early to start studying. It covers classes 14 through 18. Today we're in 17. Questions on the calendar? No, but the quest goes up to 18 and Friday's stuff is 19. So Friday's stuff is not on the quest. So you will have some time to ask questions, you know, outside of class. What we do Friday is not going to be on the quest. Other questions? All right, so starting on page 136, we'll jump up to our summary at the top. In this lesson, we examine the relationship between radicals and exponential notation. Number 1, in the previous lesson, we saw this example for simplifying the cube root of x to the 21st. So we decided that it would be really useful if the power in the front and the power up on the top could somehow match, because if they do match, then everything cancels in a big explosion and we're just left with the stuff in the parentheses. Yeah? So what does that whole thing simplify to? It's just x to the 7th by canceling the cube root and the cubed because they're opposites of each other. But we had to do work. Now this work is kind of hidden here, but where'd the 7 come from? Why 7? Yeah, it's this 21 divided by that 3. I mean, that's a shortcut that we kind of were feeling, but we didn't use it intentionally. We just said, hey, you got to put something up here so that it's still 21 at the end. And we know we multiply powers when they look like that, right? So you got to put a 7 up there so that you still have 21. So then our shortcut is that if you just take this power and divide it by that index, you get the power in the answer. Yeah? Okay, so here it is. We're going to fill in the box to come up with our shortcut. The nth root of x to the k, what divided by what in this box? K over n. Everybody see it? Like 21 divided by 3 gave us a 7. So k over n. It says put lots of stars around that formula, so let's do that here. That's going to be an important one for us today. Now it turns out that that formula is true even if when you do the division, k divided by n, you don't get an integer. Like up here we got a 7, that was a nice clean integer, but even if it's still a fraction, the formula still works. So for example, the 5th root of x to the 8th is x to the 8 over 5 by taking that 8 and dividing it by that 5 and writing it and then saying, hey, I can't do any more. This 5 doesn't go into 8 evenly, right? So that's it. It's just another way. If you see x to the 8/5, you got to say, oh, Ian is talking about this particular radical here. It's the 5th root of x to the 8th, just thinking about the division, okay? All right, there's a silly little mnemonic device. I'm not even going to read it because I'm not thrilled with it. If you come up with some way to remember whether the power goes on top or the bottom, right? The power goes on top and the number in the front, which we call the index, goes on the bottom. If you've got a good way to remember that, share it with me. I would love to come up with something better than I've got here in number 2. So 3 says rewrite this guy in exponential form. Let's try it. Negative 2y to the, is going to be a fraction. What divided by what? 13 divided by 11. That's it, right? Just got to get the order right. It's really easy to put the 11 over 13. That's wrong. Just have to know which one goes on top. Power is the one that goes on top. Now this is not a full credit answer here. What did I forget? The parentheses. At the moment, the 13/11 is only applied to what? The y. But the negative 2 was inside of that radical, just like the y was. It had parentheses before, got to have it still. Okay, so that's going from radical to exponent. We should also be able to go the other direction. In number 4, it says x to the 2/7. That is currently written as an exponent. If I see a fraction exponent, I now know that came from a radical. So let's start by putting a radical. The x is the thing inside the radical. And then it's just a matter of putting the 2 and the 7 in the right spots. One there, one there. Go ahead, write them in. The 2 and the 7, just got to put them in the right order. Which one goes in the front there? 7, and then the power is a 2. Everybody agree? 7th root of x squared. Okay, so let's take a look at 5. It says evaluate the following by first rewriting each in radical form, no calculators. So the first one says 64 to the 1/2. 64 to the 1/2. First of all, it does not mean half of 64. The answer is not 32. That 1/2 as an exponent might seem frightening in the beginning. I know what it means to square a number. I know what it means to cube a number, but what does it mean to take a number and raise it to the half power, right? It's not squared, it's not cubed, it's a half. Well, it means there's a radical floating around. As soon as I see a fraction power, I start by writing a radical. The number inside the radical is what? 64. And I'm going to put my 2 highlighted things in the same 2 spots every time. The 1 and the 2 go in those 2 highlighted spots. Just fill them in. What goes in the front? 2, and the power is 1. So apparently, 64 to the 1/2 really means the square root of 64 to the 1st. That's what it means. And so all this idea, like when I first learned exponents in, I don't know, 5th grade or something like that, and the teacher said, here's what it means to square a number, and here's what it means to cube a number, I was not prepared for dealing with the half power because it's just a completely different creature. You see a fraction up there as a power, it's a radical. So what is this answer? 8, right? That's just the square root of 64. Okay, part B is quite similar. Let's try it. See a fraction power. I write a radical. What's the number inside? Negative 64. It was in parentheses before. It better be in parentheses still. Put my 2 highlights. What's the index? 2, and the power is 1. Okay, so far so good. So this is saying take the square root of negative 64 to the 1st. Okay, well, negative 64 to the 1st is just negative 64. And what do you think about the square root of negative 64? Is it negative 8? It's not. Negative 8 is a reasonable answer. But if that were correct, then negative 8 times negative 8 should give me the negative 64, but it doesn't, right? Negative 8 times negative 8 is positive 64. So what's the answer? Yeah. Not a real number. That's a perfect answer. Not a real number. It's okay if you say undefined at the moment. Pretty soon in our class, we're going to define the complex numbers, the imaginary numbers. You might have seen I in some previous math class. So at the moment, it's something we can't go any farther with. In a few weeks, we'll be able to go farther with this. But right now, square root of a negative, just stop. It's not a real number. Okay, part C. What's the difference between B and C? The parentheses. So let's see if it affects the answer. I see a fraction power. I write a square root symbol, or a radical, I should say. What's the number that goes in that radical? It's 64. It is not negative 64. Where does that negative go? It's outside. Okay, this is something we've seen a couple of different times this semester. Powers are not very strong and they don't reach very far. And so that 1/2 power, which is going to translate to this radical, does not reach the negative. The negative is not in the radical. The only way to make it in the radical is like in part B, putting parentheses around it. Okay, we'll put our 2 highlights. We'll put the same 2 numbers in the same spots. And so this is saying negative sign is copied. Square root of 64 is 8. This one is a perfectly good real number. Big difference between B and C. Okay, next problem involves 8 to the 2/3, which we're going to do in two different ways. This one we're just going to read. It's already been typed out for us. Okay, here we go. 8 to the 2/3. We know that 2/3 is a fraction. Fraction powers mean radicals. So we've written a radical. Where does the 2 go? In the front or up on top? That 2? Does it go in the front of the radical or up on top? It goes up on top, right? So it's an 8 squared in there, and then the 3 is the index. So that's the cube root of 8 squared. 8 squared is 64. Cube root of 64 is 4. So the answer to this, 8 to the 2/3, is just plain 4. If you type it into your calculator, it will tell you 8 to the 2/3 is 4. It knows how to handle these fraction powers as well. Okay, I'm going to do this in a different way, which won't necessarily seem legitimate in the beginning, but follow me here for a second. Instead of doing the squared inside the radical, I put the squared outside. The 3 is still the index. This is still a cube root problem no matter how we slice it. But I'm going to put the square on the outside and just see what happens. What is the cube root of 8? Is 2, which is there, and the squared is still hanging out outside, right? And how much is 2 squared? It's 4, which by some miracle is the right answer. So it turns out that you are allowed to put the power inside. That's essentially the definition of the fraction power, is putting the power inside, inside, inside. But just as well, you could put the power outside, and you'll get the same answer. So given that we'll get the same answer, it turns out that there's going to be a choice that we're going to want to make that's going to make our lives easier. We'll make that choice down here in number 9, but let's take a look at the formula in 8 first. If you see x to a fraction, you write it as a radical. We know that the thing in the bottom goes as the index, the thing at the top goes as the power, but the other side of this equals has the power on the outside. So everything else is the same. Turns out it's equivalent to put the power inside or outside. Okay, here's how we handle 16 to the negative 3/4. Let's see if we can, it's already typed up, so try to ignore that thing up there. And let's just see if we can squeeze this in to the space here. Could you guys write that just in the blank space? Is there much? I think there's enough room right down there at the bottom. 16 and the negative 3/4. Okay, good first step is to deal with that negative sign. A negative, we know, involves fractions. Where does that 16 to the 3/4 go? Downstairs, and it becomes 16 to the positive 3/4, right? And we got to put a placeholder upstairs. What is it? That's a 1. Okay, so we've dealt with the negative part of the exponent. We know negative means move. In this case, 16 to the negative 3/4 was upstairs. We move it downstairs and make it a positive exponent. Okay, and now it's kind of equivalent to the problems that we've learned how to do today. So I'm going to copy this one over. I see a fraction power. What does that mean? What's the next math symbol we should write? Radical. That's it. You see fraction power, you write a radical. That will give you the structure that will allow you to fill the things in the right spots. What goes inside the radical? 16. Somehow involves a radical with 16 inside. Let's get the index going. That's the little number in the front. Is it the 3 or the 4? It's the 4. This is a 4th root problem. Now, we have a choice. This is the only choice we have in the problem. The 3 we know is a power. You are welcome to put the 3 right there. Don't put it there, but you are welcome to put it there. You are also welcome to put it here, outside of the radical. I'm going to put it in the spot that I don't want you to first. The next quest is non-calculator. Any of you happen to know 16 cubed? No, I don't either. It's actually on the wall here. I think it's these guys. 4,096. Now, the fact is, it is on your charts, like the reference sheet with the table, right? But if it's if I write it here, and again, don't write this. Even if you happen to know 16 cubed is 4,096, that still leaves you with a bear of a radical to deal with, right? The 4th root of 4,096. Maybe it's on your chart. It might not be. I actually don't know if the chart goes, no, it's not there. Okay, so 4th root of 4,096, if you could find it, you can just put it. You'll get the right answer. So I'm not saying there's anything wrong with this, but I'm saying you're not going to have a calculator in your hands on the next test. So instead of doing it that way, let's do it a better way. Go ahead and write that. We've discovered that putting the power inside or outside gives the same answer. Let's put it outside every time. 1 over something is going to get cubed. What's the 4th root of 16? 2. And 2 cubed is 8. So the answer here is 1 over 8. Which for my purposes is a whole lot easier than dealing with 16 cubed, finding out that that's 4,096, and then figuring out the 4th root of 4,096. It's 8, but that's hard without a calculator. Okay, Jeff. Anytime I have a number to a fraction, I'm putting the power on the outside. It's not even a matter of like keeping an eye out for nice numbers. It's every time I put that power on the outside. The only time I don't put it on the outside is if it had been a variable here. Like if this was an x, then the 16 becomes an x, and I say, okay, whatever. There's nowhere else to go, so I'll just put it inside. It doesn't make any difference, but that's the end of the problem. But anything numerical, I put that power outside. Okay, next page. And this will be our last example here. It's an even tougher one. It says there's a couple of ways to do this problem. We're going to simplify this mess. 35x to the negative 1/2 over 20x cubed, all raised to the negative 2. So we're just going to quickly run through the two methods here. Let's give it a shot. So in method 1, there's the original problem. The very first thing that I did here, 35 and 20, they have a common factor, right? What is it? 5. So we reduce to what? 7 over 4. So that's the very first step. 7 over 4 there. In fact, it's the same first step on the other method, which we'll look at. If you see something you can reduce, by all means, reduce before you do any crazy stuff with powers, right? Reduce first. There's only one other change that I've made here. This x to the negative 1/2. We move it to where? Bottom, and make it x to the positive 1/2. That's there. The x cubed was on the bottom. It's still on the bottom. Everybody with me? Okay, I see x cubed and x to the 1/2 next to each other. What do I do to those powers? I add them up. So we're just doing 3 added to 1/2, but I don't want to say 3 1/2. I want an improper fraction. So everybody okay getting 7/2 there instead of 3 1/2? Common denominator. Okay, so I have cleaned up the thing in the parentheses as much as possible. So the next thing I have to deal with is that negative 2 on the outside. And this is that thing which we're calling the distributive property, but that's not quite the right word. But we know the power comes in and hits everybody, right? So upstairs is 7 to the negative 2, downstairs 4 to the negative 2, x to the 7/2 to the negative 2. Yeah? Next, looking at the power on the x, what do you do with those two powers? Let's see, a 7/2 and a negative 2. What do we do with them? Multiply, right? That's one of our shortcuts from way back when. So we multiply 7 over 2 times negative 2. That's negative 7. Almost the last step is to deal with the fact that all these exponents are negative. So negative exponents we know means move. So where should we move the 7 to the negative 2? Downstairs, and it becomes 7 to the positive 2. 4 to the negative 2 moves to where? Upstairs as a 4 to the 2. X to the negative 7 moves upstairs, x to the 7. And then the last thing, don't leave 4 squared as your final answer in any problem. Just give me the single number without an exponent on it. 4 squared is 16, 7 squared is 49. We've got our answer. 16 x to the 7 over 49. All right? Okay, let's take a look at method number 2. Again, 35 and 20 reduced to 7 over 4. I have kept everything else as it is. X cubed, x to the negative 1/2. I didn't bother moving that x to the negative 1/2 downstairs. In fact, if you take a look, it was kind of a waste of effort to move the x to the negative 1/2 downstairs, because what kind of a power did we end up with on the x after we moved it downstairs? A negative power, and we ended up having to move that back upstairs anyway. So our theory of like, hey, make all the powers positive first is not always the most efficient way to get to the answer. So let's just leave the x's where they are. Let's now take this kind of complicated looking thing and bring our power in onto everybody. So quote distributing that -2. So that's this third step here. And again, we know what are we supposed to do with these powers on the x's? We'll multiply those. So -1/2 times -2 is x to the 1, super. Downstairs, x cubed to the -2, we multiply those and get x to the -6. All right, and now I'm ready to handle the fact that I've got negative exponents. So anything with the negative exponent moves. That is to say everybody moves except for which factor? The x to the first, which has a positive exponent and no reason to move. So it gets copied, but everybody else shuffles around and makes positive exponents. X to the 1 times x to the 6, what do we do with those? Add those powers and we get x to the 7. 4 squared again is 16, 7 squared is 49. Oftentimes with these complicated expressions, there's more than one way to get to the answer, and you'll get to the right answer as long as you follow legitimate legal steps. But I want to make sure that people are going slowly here, one step at a time, which means copy just about everything, but make one small change. The easiest way to get in trouble on these kinds of problems is to try to do too much in one step. Okay, the demo, that's the end of the demo. The activity starts on the next page. I will walk around. No calculators here.